Hey everyone, and welcome back to The Explainer. If you're the kind of person who loves to strip away all the noise and get right down to how things actually work out there in the real world, well, you're in exactly the right place. Today, we're taking a super fascinating look at how science operates outside the totally controlled, pristine environment of a laboratory. We're going to break down the exact parameters of Competencies 003A and 003B. Now, these act as foundational educational standards, basically detailing how individuals and especially educators should navigate the real-world application of science. These competencies outline the absolutely vital factors in scientific decision-making. So today, we're mapping out exactly how raw scientific data transforms into real-world action. Let's get right into it.
Okay, let's dive into this. Is science just facts in a vacuum? I really want you to think about that for a second. When we picture science, it's incredibly easy to just imagine a lone researcher in a spotless white coat peering through a microscope in a sealed-off room. We kind of fall into this trap of thinking about science as a completely isolated discipline, like it's just raw data, objective measurements, and absolute truths that are totally separated from the messy reality of our everyday world. But the foundational concept we're exploring today completely shatters that myth. Because as you'll see, raw data is literally only the very first step of the journey.
Section 1. Science beyond the lab. Okay, scientific decision-making. The definition here is the application of science that is heavily influenced by external human and social frameworks. This right here, this is the absolute beating heart of Competencies 003A and B. It basically tells us that the very second you try to actually use a scientific discovery, you aren't just dealing with science anymore. You're dealing with human beings. You're dealing with complex social structures. The application of science doesn't just happen in a void, right? It gets pushed, it gets pulled, and ultimately it gets shaped by these external frameworks. The facts themselves might be totally objective, but how we actually decide to apply those facts, well, that's a deeply, deeply human process.
Section 2. The 3 decision factors.
This brilliantly illustrates the balance we're talking about. Scientific application is really a balancing act, divided into 3 equal slices, as you can see. Ethical standards, economics, and personal and societal needs. Honestly, it's like a giant puzzle. If you have a brilliant, game-changing scientific breakthrough, but you ignore even one of these 3 slices, well, the application of that science is going to stall out. These are essentially the 3 gatekeepers that determine how, when, and honestly, even if scientific knowledge is ever put to practical use in our world.
Let's break down exactly what each of these crucial factors actually mean in real-world terms, right from the source text. First up, we've got ethical standards. This is that big, fundamental question of what's right versus what's wrong. Just because science can do something doesn't automatically mean we should do it, right? Ethics basically act as an objective evaluation of our societal boundaries when we're applying data. Second, we have economics. Simply put, this comes down to financial feasibility. We could literally have a scientifically perfect solution to a huge problem, but if it's economically impossible to fund or produce, yeah, it's going to remain stuck in the lab. And third, personal and societal needs. The application of science really has to be aimed at solving actual human problems. It has to serve a real purpose for the individual or for the community as a whole. Pretty much every major scientific decision you see out there in the world has been filtered through these 3 exact lenses.
Section 3. Weighing pros and cons. Now, interestingly, this places a really specific responsibility on educators. It states, teachers must apply scientific principles to weigh the advantages and disadvantages of an action. This really highlights that scientific decision-making isn't just passive. It's a super active analytical skill that actually needs to be modeled and taught to students. It involves looking at a potential course of action, really considering all the alternatives, and then painstakingly weighing the trade-offs. It's all about teaching that ability to look at a situation not just for the obvious benefits, but for any potential drawbacks, and using scientific principles as the actual grounding evidence for that analysis.
So the crucial point is really perfectly illustrated by this high-stakes scenario right from the text, balancing the environmental impact of a new factory on one hand against the economic impact of that exact same factory on the other. Say a community wants to build this facility. The economics, which, remember, is one of our 3 decision factors, might look incredibly positive, right? It could bring financial feasibility, tons of jobs, and fulfill a major societal need. But you absolutely have to weigh that against the environmental impact. What are the ecological disadvantages? Is it going to pollute the local area? Science itself doesn't make the final choice for the town, but science does provide the objective data for both sides of the argument. It gives us the hard economic data and the hard environmental data, which allows us to transparently weigh those advantages and disadvantages.
Let's move to Section 4, Everyday Informed Choices, and see how this builds.
So, zooming all the way in from the macro level of those massive factories down to the micro personal level, science provides the evidence for daily life choices. Believe it or not, you are a scientific decision maker. The exact same process of taking objective data and filtering it through your personal needs, economics, and ethics, well, that happens every single morning when you wake up. You use science as your evidence base to navigate your personal life all the time.
How does this actually work in practice? Well, take nutrition choices, for example. When you're deciding what to eat, you're actually applying scientific evidence regarding vitamins, caloric intake, and human biology to your own personal need for health. Or consider something as mundane as weather preparation. It seems so simple, right? But deciding to wear a heavy winter coat instead of shorts is literally you taking scientific data, meteorology, and atmospheric science, and making an informed choice about your societal and personal need to just stay comfortable and safe. And finally, vaccine decisions. This is a really prime example of applying science to daily life. Individuals look at the available scientific and immunological evidence regarding a vaccine, and they carefully weigh that evidence to make a highly personal, informed choice about their health and their family's health. In every single one of these everyday scenarios, science isn't making the choice for you, it's simply, but crucially, providing the evidence you need to make the choice yourself.
So, I want to leave you with a question to chew on. What scientific evidence drove your choices today? Really think about the food you bought, the way you traveled, the health choices you made. How did your personal standards, your economics, and your everyday needs interact with the actual scientific facts available to you? Understanding Competencies 003A and B isn't just about passing some test, it's really about recognizing your role as an active participant in the application of science. You are constantly weighing evidence and making informed choices, whether you realize it or not. So tomorrow morning, I want you to notice just how often you act as the scientist of your own life. Thanks so much for joining me for this explainer. Keep questioning, keep analyzing, and I'll see you next time.